Hi, this is Mrs. Kidman, and in this video, we're going to be talking about writing equations of quadratics when we're given just a vertex and a point. So what that means is, let's take a look at this graph here and see what happens. What do we know about a quadratic when we just know it's a vertex and a point? So let's look at this first one here. We want to sketch a graph that has a vertex through -2, 4. So -2, 4 is our vertex here, and it passes through the point 1, 7. So it's going to go through this point. This here is our vertex. Well, this tells us two things. Our vertex is either our maximum or a minimum. Remember that. So this means it's going to be our minimum. This is the information that our graph is telling us. First, we know that it's a minimum because this point here is greater. It has a higher y value. So that means we know that that's going to be a minimum. We also know that if I go over 3 units, I go up to the number 7. So the same thing's going to happen here. If I go 3 units to the left, we'll also have a point right here. So the graph that this looks like is something like this. So the other information that I know is I also know, so I know that it opens up. That's the minimum, right? Open up. And I also know that includes that other point of -5, 7. Because remember, it's going to be symmetric about that x equals -2. So it's symmetric about x equals -2. That's where our axis of symmetry is there. So whatever happens on one side, it's going to happen on the other. So what we're going to do with this information, when we're given a vertex and a point, notice how using that vertex and point, we could graph this entire function. We could figure out which direction it opened, what another point was, where it was symmetrical. We could figure all of those things out. So what we want to do is, instead of just sketching this graph, we want to take that vertex and that point and use it to write an equation. So let's take a look here at what we're going to do. Now, we are going to use, this here is the generic vertex form of a quadratic. And remember that this h here is the x value of our vertex, and this k is the y value of our vertex. So what we're going to do is, given that vertex, we're actually going to substitute our vertex in here for our h and k value, and then we're going to use that other point that it gives us to solve for a. So ultimately, we have y equals some number times x minus whatever the x value of our vertex is squared plus the y value of our vertex. So let's go ahead and take a look at what happens here. Now, why does it matter that we have that other point? Well, let's talk about it briefly. Remember, that vertex form looks like this, x minus h squared plus k. So if I have a point that has a vertex of -7, 8, what that means is I actually have this point of -7, which we typically write as a +7, and a +8 here. So this is what we have. Now, there are lots of equations that would work, and the reason why is because we haven't limited this a. Now, this a tells us which way it opens, how wide or thin it is, that vertical shrink or stretch concept. And so we need that other point to help us determine what our a value is. So let's take a look at how our vertex and another point can help us write an equation. So there's only one equation that we can write here. So remember, we're always going to refer back. If they give us the vertex, we want to use that vertex form. So let's refer back to our vertex form. Y equals a times x minus h squared plus k. Now I want to substitute my vertex into this. So I've got y equals, I don't know what a is, the x, our h value is -2. So minus -2 is the same as +2 squared plus our 7. Now I want to figure out what this a is. The way I can do that is I know this point is on that line. So I can use that point to solve for a. The way I'm going to do that is I'm going to set it equal just like this. So 11 is our y times a, 1 minus 2 squared plus 7. And look at that. This is what we're going for here, 1 plus 2, sorry. So then let's solve for a. Subtract 7 from both sides, 4 equals a. 1 plus 2 is 3, squared is 9. So I've got times 9. And then I want to get rid of that 9, so I divide by 9, and a equals 4 ninths. So what that means is the one equation, the one quadratic that works, that has a vertex at -2, 7, and goes through the point 1, 11 is going to be y equals 4 ninths, because that's our a value, times x plus 2 squared plus 7. And that's how we're going to find that. So again, we're going to substitute our vertex into vertex form. We're going to plug the point in for the x and y in our vertex form and solve for a, and then put it all together, just like we used to do when we had slope-intercept form. So let's take a look at this next one all together. We're going to do that same sort of thing again. So remember, we've got our vertex form here, minus h squared plus k. I'm going to use my vertex and substitute it in. So y equals a times x plus 6 squared plus 6. And then I'm going to substitute my point in there. So I've got 10 equals a times negative 4 plus 6 squared plus 6. 10 equals a times 2 squared plus 6. I'm going to move my 6 now. 4 equals a, and 2 squared is 4. Divide by 4, divide by 4. That means a equals 1. So our equation here is going to be y equals 1, or we can leave it off, x plus 6 squared plus 6. So again, we're going to substitute our vertex in right here. Substitute the vertex in, then take our other point and plug it in for x and y, and we're going to solve for a, and then use those three things together to give us our equation here. So I want you to give it a try. Using our vertex and our point, write an equation. Go ahead and pause the video, do that. When you finish, unpause the video, and we'll go over it together. So take a second to practice this one on your own. Okay, hopefully you've had a chance to go over this. Now we are using that vertex form again. I took my vertex here and I substituted it right in. Remember that our equation is minus h, and our h is our x value, our k is our y value, so a minus 10 and then a negative 5 there. Then we needed to solve for a, and the way we did that is we substituted in our point here, 8, negative 1, our negative 1 for y, our 8 for x. We used that, we moved to the 5, simplified it, solved for a, and we ended up getting a equals 1. So we can write that in our equation or not. But ultimately, writing this equation here, our quadratic that has a vertex at 10, negative 5 and passes through the point 8, negative 1, is going to be y equals x minus 10 squared minus 5. So that is how, given a vertex and a point, we can write a quadratic equation just based on those 2 points, which is so awesome. If you have any questions, feel free to reach out and we can go over them. But otherwise, this is how we go from a vertex, how we write an equation given just a vertex and another point on our graph.